solving systems of equations by substitution. In our last example, we had y was equal to a particular number. Now let's look at the second example. We have y is equal to negative 3x plus 5. And then the second equation or function is written in a standard form. When you see problems like this, always go for the equation that has a y or x is equal to a monomial or a binomial, so you can substitute it back in. So I'm going to draw an arrow showing that I'm going to substitute negative 3x plus 5 anytime I see y. So let's get ready to do it. 5x minus 4y is equal to negative 3. That is your original equation. I'm going to write 5x minus 4. 4 is being multiplied by y, but y is now going to be substituted or replaced by negative 3x plus 5, close to parentheses, is equal to negative 3. Now because we've substituted the negative 3x plus 5 into y, we can assume that we are now solving for x. So let's do our work. 5x, now negative 4 times negative 3 is going to give me a 12x using the distributive property. Negative 4 times 5 is going to give me a negative 20. Notice I did not add the two terms inside the parentheses. They're unlike, so I use the distributive property. Is now equal to negative 3. Let's combine like terms on the left side. 5x plus 12x gives me 17x minus 20 is equal to negative 3. The opposite or the inverse of subtracting 20 would be to add 20, so I can isolate my expression with the variable. The 20s cancel out and I'm left with 17 x is equal to 17. I want to get x by itself or isolated. The inverse is to divide by its coefficient of 17 on both sides. 17 will go into 17 one time, which leaves me x. 17 divided by 17 is 1. So we're writing the first part of the solution, which is your x-axis value, is 1. But I can't just have x, I need to also have y. So let's find y. So x is equal to 1 as part of our solution. So now we need to find y. You have two options. You can plug x equal to 1 into the second equation, or the first one where it's already set for y is equal to negative 3x plus 5. I'm going to recommend you use the first one. It's the easier one. So let's substitute it in. Y is equal to negative 3x plus 5. Y is equal to, now this is where we're going to substitute our given x, our found x. Negative 3 times 1 plus 5. Negative 3 times 1 is negative 3 plus 5. If you owe somebody $3 and you give them $5, you would expect back $2. So y is equal to 2. So now I'm going to put together the two numbers. My x is equal to 1 and my y is equal to 2. So the solution is 1, 2 on a coordinate plane. Now you might be saying, how do you know that your answer is correct? We're going to erase it real quick. I'm going to write the two equations. Y is equal to negative 3x plus 5. And then 5x minus 4y is equal to negative 3. Where I see y, I'm going to substitute a 2. Where I see x, I'm going to substitute a 1. So negative 3 times 1 plus 5. And then for my second one, 5 times 1 minus 4 times y, which is 2, equals negative 3. 2 is equal to negative 3 times 1 is negative 3 plus 5. This gives me 2. The difference of it is 2. 2 is equal to 2. So far, the solution makes the first equation true. 5 times 1 is 5. Negative 4 times 2 is negative 8. And it should equal to negative 3. If I have $5 in my pocket, but I try to spend $8 at the store, I still owe them negative $3, and negative 3 is equal to negative 3, so the solution makes this second equation true, so therefore we can